Hey guys, so today we're going to move into two different sequences, or actually three different sequences that kind of go along with our exponential growth and decay formula and our linear formula and our linear function. Today, we're going to look at the arithmetic sequences that's similar to our linear function, but it's a little different. And then tomorrow we're going to move into something called the geometric sequence, which is similar to our exponential growth and decay formula. So today we're going to look about is how do we find specific terms in an arithmetic sequence. So what we're going to ask you to do is take out packet 10. If you don't have it, please either print it out or go along with me in this video. It's really important that you guys try the problems so you know what we're talking about later on in the future. So if you look at the do now, I want you to look at and see it asks you to find specific terms in the sequences that you find below. There is a pattern, and I want you to try to find the pattern and figure out how you would get to the next three numbers in the sequence with the pattern without using the video. So pause the video and see if you can answer the question. So an arithmetic sequence, I just want you to make sure you take down all the necessary notes and that aren't on the paper, just because we're going to add to each slide, and each piece is really useful in the upcoming lessons. So the first part of the do now, if you notice, each term in the sequence was being added by 3 to get to the next term in the sequence. And the next three terms would be 16, 19, and 22. In the one below, we notice that we're subtracting 3 from each term. So to get to the next three terms in the sequence, we would have to do 8. We'd get 8, 5, and 2. Now, these are considered arithmetic sequences because we're adding or subtracting by a common number, and we call that number our common difference. Even if we're adding or subtracting, or it's positive or negative, it just has a specific name called the common difference. These terms are considered our first terms in the sequence. And then we go to 7 and 17. Those are our second term in the sequence. And those are our third term. And then if you look at the next purple boxes, those are our fourth terms in the sequence. And so on and so forth. So each term has a specific place in a sequence, and those are important to know. We also, if we're not sure of a term number, we call it the nth term. It's a general term that we talk about in the upcoming future. And just like I said before, these are called arithmetic sequences, just so you know that's the name we give it. Now for 3 and 4, you should have noticed that number 3, we were multiplying by 2 to get to each term in the sequence. Now, many of you may have said, oh, we were adding 1, then 2, then 4, then 8, which would give it to you. But generally speaking, we want to find a common number that we're either multiplying by, adding by, subtracting by, or dividing by. If you can't find a common number, you have to try a different operation. The next three terms should be 16, 32, and 64. Now in number 4, many of you had thought maybe we were taking away a 0, but in math, that really just means we're dividing by 10. So the next three terms should have been 30, 3, and 0.3. We call these type of terms geometric sequences. So just know that when we're multiplying or dividing by a common number, we call those geometric sequences. And that common number is something called a common ratio. Now, when we're multiplying a number, it'd be multiplied by 2. But here we're dividing by 10. We consider that multiplying by 1/10. So just be aware that when we're dividing, we really think of it as multiplying by a fraction. And we'll get more into that tomorrow. I'm just going to ask you to flip it over to the next page, and we're going to explore this question. It says, what is the 20th term of the sequence below? It's the same sequence we talked about before, but now we need to get up to, not only do we have the first, the second, the third, and the fourth term, we need to go all the way down to the 20th term. That might take us a long time to find, but we do have a formula that could help us get there quicker. And that's what we're going to explore today. How to find really big terms in a sequence, like the 100th term or the 1,000th term. Rather than just generating the numbers in the sequence, we're going to use a formula. And the formula we use is called the arithmetic sequence formula. And this is found on our reference sheet on the Regents. And it looks like this. And these letters and symbols kind of look a little crazy. So we're going to go over each single one number term. And I want you to make sure you copy this down as you go along and pause the video. Now, A sub n is the actual answer to the term that we're looking for. So say we're looking for the 100th term and it comes out to 565. We would put 565 for that down. A sub 1, that's this term right here, that's our first term in the sequence. So that's whatever comes first in the sequence of numbers. N is the term number. So if we're looking for the 100th term, that would be the number we plug in here. For this next one, we're doing the 20th term. So 20 would be that number. The 1 stays there. And then we have our D. Our D is our common difference. Now remember, if the sequence increases, it's a positive number. If it decreases, it's a negative number. So pause the video and make sure you have all this down. Now we're actually going to use this formula to find the 20th term in the sequence 4, 7, 10, and 13. First thing you're going to do is write down the formula. Second thing you're going to do is label each one of our terms. So our first thing in our formula, because we're looking for this term, we're not going to label it. We're going to fill in the information that we have. We have A sub 1, which is our first term, which is 4. N is the 20th term. It tells it to you in the problem. So it's 20. And D is our common difference. It's the number that we're either adding or subtracting by to get to each term in the sequence. Your next step is you're going to fill the information into the formula. Since N is 20, we're going to put that down here just to remind us we're looking for the 20th term. We're going to plug 4 in for A sub 1 because that's our first term, 20 in for N, and 3 in for D. Now your next step is just to evaluate. So you're going to plug this into your calculator. And when you plug it into your calculator, you should get A sub 20 equals 61. Now this is not changing the A sub 20. The A sub 20 stays there. It's the 61 that actually gets a number to it. So all that tells us is the 20th term of the sequence is 61. Okay? So let's try the next one together, and then you're going to have a couple to try on your own. We want to find the 100th term in the arithmetic sequence, 20, 17, 14, and 11. So the first thing you're going to do is write down the formula. The next thing you're going to do is label each part that we're going to plug into the formula. A sub 1 is our first term. N is the number in the term we're looking for, which is 100. And D is our common difference. Now in this one, we're going down by 3, so it should be negative 3. Next step is plug into the formula into the appropriate spots. 100 goes in for N. 20 goes in for A sub 1 because it's our first term. N goes in as 100 because that's the number we're looking for, minus 1, and then we're going to multiply that by negative 3. Now remember, when you plug it into the calculator, you have to remember to use parentheses like you see in the problem, or else you're going to get a different answer. And you plug it in, and you should get A sub 100 equals negative 277. Okay, so what I'm going to ask you to do is stop the video and make sure you have everything written down for this part of the packet, because you're going to need it to go back to try the questions that you're going to be asked to do on the Google form in the Google Classroom on arithmetic sequences. They're the same problems in the packet, but they're just in digital form. Okay, so good luck, and if you have any questions, just email me.